Hello dear friends, welcome to my channel BSc Mathematics Dr. S.S. Pulsagar. I am in my agricultural farm field where I am now going to record a video on complex analysis. So this is our agriculture farm field. Here we have made a small shelter and we have planted some trees, flowers and fruits. The farm is located in our hometown, which is Hiraz, Tehsil, North Solapur, district Solapur, Maharashtra, India. We have here a well for agriculture irrigation, and these are some trees: mango, papaya. This is water apple, banana tree. This is well for agriculture purpose, irrigation purpose, and we have cultivated sugar cane and other trees are also there. So I have put the board for recording lecture here in a small garden we have done with trees here. You can see here we have a plant for vermiculture. So thanks for seeing this. Now we shall start our lecture. We shall study arguments of a complex number in this lecture. We shall also study what is principal argument. We shall have some examples and properties. So we shall start with arguments of a complex number. We will consider Z as a complex number, which is written as order pair x comma y, or in the form x plus iy, be a complex number. And we have studied earlier the modulus of complex number, which is mod z, and let R be mod z actually. Let R be the geometrically it represents length of the vector z. And that means this R is absolute value or modulus of z. Further, let theta be the angle made by vector z with positive x-axis. In anti-clockwise sense. And the figure for this will be, suppose this is complex plane, x-axis and y-axis, and this point is z, and we shall denote the vector z is the point x comma y, and this is the vector z, and the absolute value of z is r. That means this length oz is r. And now the coordinates, rectangular coordinates of z are x comma y. So therefore this distance, if it is perpendicular from z on positive x-axis, then this distance is x and this distance is y. So or this length is y, and therefore the relation between the polar coordinates and what is further written, theta be the angle made by vector z with positive x-axis, and in anti-clockwise sense means this angle is theta. And therefore from simple trigonometry now, this is right angle triangle and we have cos theta. See, cos theta is equal to adjacent side divided by hypotenuse, that is x upon r, and sin theta is the opposite side divided by the hypotenuse, that is y upon r, and thus the polar and Cartesian coordinates are related by these two equations, which gives x is equal to r cos theta and y is equal to r sin theta. Then the Cartesian and polar coordinates are r and theta, r of z are related by x is equal to r cos theta, y is equal to r sin theta. And from this it is easy to note that the value of r, which we have written here as mod z. Now squaring and adding, we get x square plus y square, left side square sum of square, and right side is r square cos square theta plus r square sin square theta, which is r square. And therefore x square plus y square is equal to r square gives r is equal to under root of x square plus y square. Similarly, to get theta, we take the ratio of y and x. And what is y upon x? Y upon x is r sin theta divided by r cos theta, which is tan theta. And therefore, tan theta is equal to y upon x. So this is the relation between Cartesian and polar coordinates that we have. And now with this help of this notation x and y, now we further rewrite z. Now z is equal to, z is x plus iy, and that is now x is r cos theta plus y is r sin theta, or therefore the expression for z becomes r is common in bracket x cos theta plus I sin theta. So this is the expression for z. Now in this expression of z, r is the modulus or length of the vector z, and theta now is called the argument of this complex number z. So we can write now the definition actually for argument z. The real number z, the real number theta for z is equal to, for a complex number z, z not equal to 0 and z is equal to r cos theta plus I sin theta is called argument of an argument of z. Written as ARG z. In short, we write this as ARG z, and thus ARG z is equal to theta. Therefore, ARG z is equal to theta. And what is theta? From this relation, tan theta is y by x, so theta is tan inverse of y upon x. So thus this is the expression for argument z. Whether this value is argument z, whether it is unique, no, because if you consider the angle theta plus 2 pi, then we will get this as theta, and again add 2 pi to this, so we get the same position, and that means same position of this point z. So therefore argument of z is theta, and which is equal to, see, theta plus 2 pi, and therefore there are infinitely many values of argument z, and we mention it as theta is measured in radians. Argument z is equal to theta is measured in radians and has infinite values, infinitely many values, which differ from theta by integral multiple of 2 pi. have argument z is equal to theta, and that is again equal to theta plus 2n pi, where n is integer, positive or negative. And thus there are the infinite many values of argument of z. Now we shall define principal argument, and we shall see what is the difference in or relation in argument and principal argument. For that purpose, we consider a non-zero complex number z. If z is not equal to 0, then the principal argument of z denoted by or written by capital ARG. General argument we write small arg, and for this see, this is general argument, it has infinitely many values, but principal argument is having unique value denoted by capital A RG of z is the unique value of argument z, such that minus pi is strictly less than argument z is less than or equal to pi. So that means that value of argument z which lie between minus pi to pi is known as principal argument of z, and denoted by capital A RG of z. So here if you consider this point, then the value of theta is principal argument, because it lies between 0 to not 0 but minus pi to pi. What is the notation minus pi to pi? 0 to pi is the angle. See, this angle is 0 to pi. And what is minus pi? 0 to minus pi measured in clockwise sense is positive, and measured in anti-clockwise sense is positive, and measured in clockwise sense is negative. So this is minus pi and this is plus pi. So that means the value of theta which lie either in 0 to pi or 0 to minus pi is taken to be principal argument. And here minus pi is excluded. Minus pi is strictly less than, because minus pi is this position which is same as pi, and if the point is a negative real number, then its argument is to be considered as pi. So for example, see what will be argument of minus 3. Argument of minus 3, see this point minus 3 is on the negative x-axis, say minus 1, minus 2, minus 3, this point. And therefore the argument of minus 3 means minus 3 comma 0, and the angle made by this vector minus 3 plus 0i is this one, and which is pi. So this is equal to pi, or argument of any negative real number is to be considered as pi. Now second example we will have what will be argument of 1 plus I. 1 plus I is the point in the first quadrant. See, that is the point corresponding here is minus 3 comma 0, and here the point is 1 1. So therefore this is in the first quadrant, and therefore this is the point 1 1, and the angle here, it bisects the first quadrant, pi by 4. So therefore this is pi by 4. Likewise we can have in the second quadrant, and for that we may consider the point as argument of minus 1 plus I, and this will be minus 1 plus 1 point. and therefore it bisects the angle in the second quadrant, and that the argument will be this angle made with positive x-axis in anti-clockwise sense, and this angle is up to this is pi by 2 and plus pi by 4, and therefore this is 3 pi by 4. So next we may have argument of -1 minus I, both negative here, x coordinate and y coordinate, and therefore this is -1, this is -1, and the point will be this one. So here we should not take the angle in anti-clockwise sense, but we should take the angle in clockwise sense, because it must be between minus pi to plus pi. If you measure the angle in this sense, it will be greater than pi, and therefore here the angle is measured in clockwise sense. And what is the measure of this angle in clockwise sense? Up to this is pi by 2 and this is pi by 4. Pi by 2 plus pi by 4 is 3 pi by 4, and but because the angle measured in clockwise sense are to be considered as negative, and therefore the argument of minus pi minus -1 minus I is minus 3 pi by 4. You note this. And one more example we will have for the fourth quadrant. So what will be argument of say in general I shall consider -3 plus -2 plus 3i. Here see what is the quadrant is, the point actually is coordinates, Cartesian coordinates are -2, and therefore this will be x, y. We want to consider fourth quadrant, so this should be positive and this should be negative. Y is negative, 2 minus 3i, and this is 2, this is -1 minus 2 and -3. Therefore the point will be here, and this is the angle. But what is the actual angle that can be calculated by formula tan inverse of y upon x, and therefore here we will have it as tan inverse y upon x theta. But in that case we shall measure the angle as, see, it is in the theta is equal to tan inverse of y upon x, and that is theta is equal to tan inverse of what is y is -3 and x is 2. So thus this is the principal argument. Argument z is tan inverse of -3 by 2 or minus tan inverse of 3 by 2. Now the principal argument, we can remember how to obtain the principal argument. See, if z is not equal to 0 and z is equal to x plus iy, then principal argument of z is given by, say, tan it is a argument of z, principal argument of z, this is the notation, and we shall write as this one, which is simply tan inverse of y upon x. If x is positive, y is positive, x greater than 0, y greater than 0, and that means the point lies in the first quadrant. And now if this is pi plus tan inverse of y upon x, if x is negative and y is non-negative, that means in the second quadrant pi plus this point, x is positive, y is x is negative, y is positive and non-negative, that means in the second quadrant, and this is the expression for argument z. And for the third quadrant, in which both negative, it is minus pi tan inverse of y upon x. Why we are considering this? Because the angle should lie between minus pi to plus pi, and here it is both x negative, y negative. And for this, here we have x is greater than 0, x is greater than 0, and y is positive, y can also be considered as negative, and therefore only the condition is x greater than 0. And now for this fourth quadrant, it is the same. Fourth quadrant and first quadrant, the formula is the same. Now it is pi by 2 when x is 0, y greater than 0, and it is negative pi by 2 when x is 0, y is less than 0. So thus these are the values, and it is indeterminate when x is 0, y is 0. The argument z is not defined. So this is the expression for argument of z that we should remember. So general example can be considered as find argument of, say, root 3 minus, we shall consider this as minus root 3 plus I, argument of this complex number. So we can use these formulae here. Here z is minus root 3 plus I, and therefore x is minus root 3, this is x plus iy. X is minus root 3 and y is 1, and the point z lies in which quadrant? See, negative x and positive y, means second quadrant. It lies in second quadrant. Z lies in second quadrant, and therefore argument z is equal to, now that we will have, say, for the second quadrant, this is the formula, by formula of argument z, pi plus, so pi plus tan inverse of y upon x. Y is 1 and x is minus root 3, or that is pi, we can have this minus sign outside. Tan inverse of minus theta is minus tan inverse of theta. This is tan inverse of 1 by root 3, and we know what is the tan inverse of 1 by root 3. We have tan 30 or tan pi by 6. Tan pi by 6 is 1 upon root 3, and therefore this is pi by 6. Since tan pi by 6 is 1 by root 3, and therefore this value is 6 pi minus pi is 5 pi upon 6, and certainly this is less than pi, or it lies between minus pi to plus pi, and this is argument z. So it is easy to find principal argument. First write z in the form of x plus iy, and then note the point in which quadrant it lies, and according to that use this formula. So therefore we have studied in this lecture what is argument and what is principal argument and how to find. The remaining part we will continue in our next lecture. Thank you for watching the lecture.